Alright, for this video we're going to go over Module 1, Homework 4 for Intermediate Algebra. We're going to talk about rationalizing radical expressions. So rationalizing an expression that has a root in it. So the first thing says rationalize the denominator, the square root of 7 over the square root of 6. So what that word rationalize means is we're going to get rid of the radical in the denominator. So we're going to get rid of the radical in the denominator. So I have the square root of 6. So I know because it's a square root, I have to have 2 of a kind in order to come outside of the radical. So I need one more 6 underneath the radical. So I'm going to multiply the top and the bottom by the square root of 6. I'm allowed to do this because we do to the bottom, do to the top, because I'm really multiplying by a fancy way of writing 1. The square root of 6 over the square root of 6 is just a fancy way of writing 1. So underneath the radical now, on the top, they're both square roots, so I can write it underneath the same square root. 7 times 6 will give me 42. On the bottom, I have the square root of 6 twice, so I have the square root of 6 squared. So the square root and the squared cancel each other out. And I'm just left with the square root of 42 over 6. That is my final answer. So a lot of questions come up with this because why can't I simplify this 6 and the 42? They are not like terms. This 42 is underneath the radical, this one is not, so I cannot simplify those two things. So the next question says, what does rationalizing mean? Again, rationalizing means just we're gonna be getting rid of the radical, whether it's in the numerator or on the denominator, but this class we only do rationalizing the denominator. So why are we allowed to do this? Because we are technically not changing the function, we're just changing the way it looks because we're technically just multiplying by a fancy way of writing 1. So for my next example, rationalize the denominator. I have the square root of 25 over x. So as we talked about, we can split this up and say it's a square root of 25 over the square root of x. So I know the square root of 25 is 5 over the square root of x. So again, I'm trying to rationalize the denominator. I'm trying to get rid of the radical in the denominator. So I have this square root of x. So I need another square root of x underneath the radical. So what you do to the bottom, do to the top. So I'm going to multiply the top and the bottom by the square root of x. So up top I have 5. It's not under a radical, so it goes outside. Times the square root of x over the square root of x times the square root of x, which is the square root of x squared. So the square root and the squared cancel each other out. I'm just left with 5 square roots of x all over x. Final answer. Again, we cannot cancel out these x's because they're not like terms. This x is underneath the radical, this one is not. So that's our final answer. So next page. Again, I'm going to rationalize the denominator. I have 7 over the square root of 45x. So I'm going to multiply the top and the bottom by the square root of 45x. Because that will give me up top 7 square root of 45x over, I have the square root of 45x times the square root of 45x. So I have the square root of 45x twice, so the square root of 45x squared. Square root and squared are going to cancel each other out. So on the bottom, I'm just left with 45x. And again, on the top, I'm left with the 7 times the square root of 45x. Notice it says rationalize the denominator, so I'm only worried about getting the radical out of the denominator. So that is my final answer, big thing. All of that is underneath the radical, so I need to make sure that that's written to show that. All right, let's keep going. So rationalize the denominator. I have 2 times the square root of 5 over the square root of 3. So I'm trying to get rid of that square root in the denominator. So I'm going to multiply the top and the bottom by the square root of 3. So on top I have a 2 out front. And then underneath the radical I have 5 times 3. I'll just write that out as 5 times 3. They're both square roots, so I can write it underneath the same square root. And then I have the square root of 3 times the square root of 3, so I have the square root of 3 squared. So the square root and the squared cancel each other out. On top, final answer, 2 square root of 15 all over 3. 2 and 3, those are like terms, so if possible those could be simplified, but there's nothing that 2 and 3 have in common. So that's my final answer. These two are not like terms. The 15 is underneath the radical, the 3 is not, so I cannot simplify those two. Next question. Rationalize the denominator. I have the square root of 3x over this 2y. So they're both underneath the radical, so I can split it up and write them separately under their own radicals. So I'm trying to rationalize the denominator. I'm trying to get rid of that radical in the denominator. So I have the square root of 2y, and because it's a square root, I need 2 of them in order to come outside the radical. So I'm going to multiply the top and the bottom by the square root of 2y. What you do to the top, you have to do to the bottom. So up top, I have a square root times a square root, so I can write them underneath the same square root. So the square root of 3x times 2y. On the bottom, I have the square root of 2y times the square root of 2y. So I have the square root of 2y squared. Square root and squared cancel each other out. So up top, combine in like terms, I have the square root. 3 times 2 will give me 6 times an x times a y, all underneath the radical. On the bottom, I just have 2y. Those are not like terms, so they cannot be simplified. So that's my final answer. All right, so this is where it gets different. So if you notice for this one, it says rationalize the denominator. I have 8 over 1 minus the square root of 5. So this time, not only do I have a square root, but I also have that 1 minus out front. So if I were to multiply by the square root of 5, I would have to distribute. So 1 times the square root of 5, I would still have a square root underneath the radical. That's my whole point. So whenever you have this situation where it's 1 minus the square root of 5, or so some number plus or minus a radical, something like that, I'm going to have to use the conjugate. So what the conjugate means is I'm taking the same thing. So I have my 1, I have my square root of 5, but my middle sign is changing. So this time I have 1 plus the square root of 5. Just like we did before, what you do to the bottom, you have to do to the top. Because this is just a fancy way of writing 1. 1 plus the square root of 5 divided by 1 plus the square root of 5 is just 1. So that's what's called the conjugate, where we are going to change the middle sign. All right, so let's see how this works. So I have 8 times 1 plus the square root of 5. So I have to distribute my 8. So 8 times 1, give me an 8. 8 times the square root of 5. So plus 8 square roots of 5 all over. Distributing this, so I have 1 times my 1. 1 times positive square root of 5, so plus square root of 5. I don't have to write that 1 out front because I know that there's 1 square root right there. So now distributing my negative square root of 5. So negative square root of 5 times 1 will give me negative square roots of 5. Last but not least, I have negative square root of 5 times positive square root of 5. So negative times a positive will give me a negative. I have the square root of 5 times the square root of 5. So I have the square root of 5 twice. I have the square root of 5 squared. So if you notice, a couple things happen here. Plus square root of 5 minus square root of 5, they cancel each other out. That is the whole point of a conjugate. The middle terms cancel out. Also, I have the square root and the squared cancel each other out. So simplifying this on top, I still have 8 plus 8 square roots of 5. All over on the bottom, I'm left with 1 minus just my 5 left over. So 1 minus 5 will give me a negative 4. Oh, sorry. All right, last but not least, I'm dividing this whole fraction by 4. So this 8 gets divided by 4 and this term gets divided by 4. So I can rewrite that as 8 divided by 4 plus 8 square roots of 5 divided by 4. 8 divided by 4 is 2, so I'm left with 2 plus 2 square roots of 5. It's hard to write this with one hand. Okay, so that's my final answer. So again, we multiplied by the conjugate, so my middle terms would cancel, and the square root and the square would cancel, so I got rid of my radical in the denominator. So I was left with 8 plus 8 square roots of 5 over 4. So I'm dividing the whole top by 4, so each term gets divided by 4. 8 divided by 4 gives me 2. 8 divided by 4, again, these are light terms because they're outside of the radical. This square root of 5 just stays there because it is left underneath the radical, so it's not the same. 8 divided by 4 is 2, so 2 plus 2 square roots of 5 is my final answer for that one. All right, last page of notes for this section. So to kind of generalize that, so to find the conjugate, we are going to change the middle sign. We're going to change the middle sign. So find the conjugate of the expression, the square root of 13 plus c. So for the conjugate, all we're going to do is change that sign. So it's positive, now becomes negative, done. It was positive and now becomes negative. That's the only thing that's changing is that middle sign. Next one, so find the conjugate of the square root of 14. So there's really no middle sign here, but the whole part of the conjugate is the opposite. So the opposite of positive 14, negative 14, negative square roots of 14. Also, if you want to think about it this way, we have nothing plus the square root of 14. We're going to change this middle sign to a negative. It's positive, we're going to turn it to a negative. 0 minus square root of 14 is just negative square roots of 14. So it's another way to think about that. Same concept, I have 2i. There's nothing, no middle sign. So just like before, it's positive 2i. This will be a negative 2i. Or just like we talked about earlier, I have 0 plus 2i. Changing my middle sign as a positive, changing that to a negative. I have 0 minus 2i, which is just 2i. And last question, find the conjugate of the expression negative 3 square roots of 5 plus 8 square root of z. So I'm just changing the middle sign, just that one. So I have negative 3 square roots of 5. It's plus, now it's going to become minus 8 square roots of z. So notice that negative out front never changed. The only thing that changed was that middle sign, and that's my final answer. So this is Module 4, Homework 2, Worked Out Notes for MAT 1033 Intermediate Algebra.